Hello students, let us start the new chapter, chapter number 3, Understanding Quadrilaterals. Quadrilaterals is not a new concept. We have learned in class 6th and 7th the meaning of quadrilateral and different types of quadrilaterals. In class 8th, we will be revising what we had studied, and then we will understand the properties of each of the quadrilaterals and also the properties related to the sum of angles in quadrilateral and in any polygon. To start with the chapter, we need to understand the meaning of plane figures. For that, we should know what is a plane surface. A flat surface like paper is a plane surface. We have seen different pages. These pages of a book, they are plane. The surface of the green board or a black board is also a plane surface. What is a plane curve? When we get a curve by joining the number of points without lifting the pencil is called as a plane curve. When we draw, it could be an open curve or a closed curve. For example, look at these figures. These figures are open curve. Look at these figures. These are closed curves. These are open curve. These are closed curve. It's also called as an open figure and a closed figure. We have to start drawing a figure using a point, initial point. Here you observe this is initial point. This one is a final point or the end point. This initial point and end points are different. In these figures, if I start from here, this is initial point. I start drawing and I end at the same point. So the initial point and the end point, they remain the same. Such type of figures which are obtained by joining both initial point and final point or end point, they are called as closed figure or a closed curve. Here you can observe in the closed curve, few of them they are having line segments, and one of the figure here it has got curve. These type of figures wherein the line segments are present, they are called as polygon. The simple closed curves which are made up of line segments only are called the polygons. If 3 line segments are there, it forms a triangle. If 4 line segments are there, it forms a quadrilateral. So, depending on the number of sides or the number of line segments it's made up of, we give names to the polygon. Let us understand, if 3 line segments are there, it is called as a triangle. If 4 line segments are there, it is called as a quadrilateral. If 5 line segments are there, it's called as a pentagon. 6 are there, it is called as a hexagon. If 7 are there, it is called as a heptagon. If 8 are there, it is called as a decagon. If 9 are there, it is called as a nanogon. If 10 are there, it is called as a decagon. If n number of sides are there, it's called as n-gon. Look at these polygons. Here it has got 3 vertices. These 3 vertices are adjacent to each other. If I name A, B, C as the vertices, A, B and C, they are adjacent to each other. Suppose if I name PQRS as the name of the quadrilateral, with respect to the point P or vertex P, Q and S, they are adjacent and R is opposite. P and R are opposite vertices. With respect to vertex Q, vertex S is opposite. With respect to vertex Q, vertices P and R, they are adjacent. You need to know the opposite vertices and adjacent vertices so that we can define diagonal. A diagonal is defined as any line segment which connects two non-consecutive vertices of a polygon. Look at these figures here. The triangle, it has got 0 number of diagonals because the non-consecutive vertices are missing in triangle. Whereas in a quadrilateral, there will be 2 sets of non-consecutive vertices. If I name this as K element, K is opposite of N. K and N, they are non-consecutive vertices. M and L are non-consecutive vertices or opposite vertices. In the case of a pentagon which is having 5 sides, there will be 5 number of diagonals. In case of a hexagon, there are 6 sides and there will be 9 pairs of non-consecutive vertices, hence 9 diagonals are present in a hexagon. Remember, there is a formula to find out the number of diagonals. The formula is n into n minus 3 divided by 2. This formula, you are going to use it in higher classes. However, it's easy to understand. If n is the number of sides, if triangle has got 3 sides, 3 minus 3 by 2, which is 3 times 0 by 2, which is equal to 0. 0 number of diagonals are present. If 4 is the value of n, 4 minus 3, 4 into 4 minus 3 by 2, this is 2 times. So 2 diagonals are present in a quadrilateral. If a polygon has got 10 sides, that is in a decagon, the number of diagonals will be 10 into 10 minus 3 by 2. 5 times, so 5 times of 7, which is 35. So 35 diagonals are there in a decagon. Whenever there is a curve drawn on a plane, there will be 2 regions formed. They are called as interior and exterior. Here, the blue shaded part represents the interior and exterior of the closed curve. Here, this is interior. This part outside, it is exterior. When we think of a polygon, there will be two types. They are convex and concave polygon. What are these convex polygon? The polygon which have all the diagonals inside the figure, they are known as a convex polygon. Look at the figure here. The diagonals are inside the figure. There are two diagonals here. They are inside the figure. It's a convex polygon. The polygon which have some of its diagonals outside the figure, they are called as concave polygon. I've taken a simple figure here. Look at this. This figure has got two diagonals which are not inside the figure. One of the diagonal is outside, the diagonal BD is outside. So it is a concave polygon. Next we have regular and irregular polygons. Polygons which are equiangular and equilateral, they are called regular polygon. That is, a polygon is regular if they have got all the sides equal and all the angles equal. Few of the example for regular polygon is a triangle and a square. They are regular because all the sides are equal, as well the angles are equal. Here in a isosceles triangle, this is isosceles right angle triangle, the sides are not equal and angles are also not equal. Here 90 degrees is the larger angle, other two angles are acute. In this figure, rectangle is also not regular. Though the angles are equal, the sides are not equal. A square is a regular polygon, but rectangle is not, as its angles are equal but the sides are not equal. This you must remember. Next we have angle sum property. The sum of all the interior angles of a polygon remains the same according to the number of sides regardless of the shape of the polygon. And the sum of interior angles of polygon is given by n minus 2 into 180 degree, where n is the number of sides of a polygon. For a triangle, sum of interior angles is 180 degree. For a quadrilateral, it is 360 degree. Look at this. In general, if n number of sides are there, sum of the angles will be n minus 2 into 180 degree. You must note that it is applicable to both convex and concave polygon. Let us discuss some of the measures of exterior angles of polygon. The sum of the exterior angles of a polygon is always 360 degrees. This is used to find the number of sides in a regular polygon. Look at these figures here. Here the angle inside is 60, exterior is 120. There are three exterior angles. 3 times of 120 is 360 degrees. Here 4 and exterior angle measure is 90 degree. So 4 times of 90 degree is again 360 degrees. Here there are 5 sides. 5 times 72 degrees is 360 degrees. Look at this irregular polygon. The exterior angles are 24 degree, 102 degree, 81 degree, 63 degree and 90 degree. Sum of all the exterior angles here is 360 degrees. Let us take up quadrilateral. Any closed polygon with 4 sides and 4 angles and 4 vertices are known as quadrilateral. It could be a regular or irregular polygon. A regular quadrilateral will be having all the 4 sides equal. A irregular quadrilateral will be having the sides different from each other. Let us understand angle sum property of a quadrilateral. Sum of all the interior angles of quadrilateral is 360 degree. At the same time, sum of the exterior angles of quadrilateral is also 360 degrees. There are different kinds of quadrilaterals. Depending on the sides, angles and diagonals, they are categorized. The different types of quadrilaterals are on the basis of their nature of sides and their angles. First we have a trapezium. Trapezium is a quadrilateral in which one pair of parallel sides are present. In the quadrilateral ABCD, we have got the side AD parallel to the side BC. So it is a trapezium. In quadrilateral ABCD, AB and DC, they are non-parallel sides. If these non-parallel sides are equal, then the trapezium is named as an isosceles trapezium. The next type is a kite. If two pair of adjacent sides are equal in a quadrilateral, then it is called a kite. This is how a kite looks like. Observe carefully, the side AB and BC are equal, AD and CD are equal. Two pairs of adjacent sides are equal. There are few properties related to the kite. The two diagonals, they are perpendicular to each other. Means angle AOD will be 90 degree. One of the diagonal bisects the other one. Here, the diagonal BD bisects the diagonal AC. If BD bisects AC, then AO will be equal to OC. These two parts will be equal. In kite, angle A and angle C are equal where the diagonals are bisected. These two angles are equal, but angle B is not equal to angle D. These are few properties you must remember. We shall take a few more quadrilaterals and learn their properties in the next session, followed by a few questions. That's all for today's session. Thank you.